kind of part of the original plan? Because I think a lot of like deep tech companies or hard tech companies, it's very hard for them to find a way to monetize, and it usually takes a long time, or they have to be very reliant on the government. But you've kind of managed to both get pharma and potentially other companies there, but also work with government as well.
Yeah, I mean, from starting the company, we always knew that we had an interest in where these pieces of technology that we were going to pursue for that commercial kind of North Star, that as we found overlap with government work, we were not going to shy away from that.
Right.
At the same time, we and I think everyone here is particularly interested in being the first company to really solve this orbital manufacturing piece. And so look, if there was a government customer of any ilk that said, hey, we know you're working on this, but we want you to work on something completely tangent to that, we'd probably say no to that. And we have in the past.
Got it.
But where our technology suite has overlapped with some of those other mission sets, absolutely. We know how to perform on that. We have a lot of folks in and around this company that are very well versed in that type of work, and so it's a really natural fit for us. Even though I recognize that when you're building a business, ours can seem a little odd in that we're doing re-entry hypersonic tests on exotic heat shields that are going to eventually go to Uranus, and then at the same time, we're working on formulations of different drug products.
Right.
But when you kind of piece it together with a piece of technology that we have, I think it makes a bit of sense. So.
Yeah. Cool. So. Eric, thank you for coming today. Today we're here at the Varda Space Industries offices.
Yep.
Varda is one of the companies I was really, really excited to come meet. We had talked about it on our podcast before, and so thank you so much for letting us come in and come visit your offices.
Please, thanks so much for coming by. Excited to tour you around and talk a bit about what we've been up to for the past, I don't know, a little over 4 years now.
Yeah.
So quick.
Can you give a quick background about who you are, and then just a quick overview about Varda?
Sure. So my name's Eric Lasker. I'm the Chief Revenue Officer and part of the founding team over here at Varda. So oversee, as I jokingly say internally, all things making this an actual viable business on a good day.
Right.
And I think we'll get into my background later, so I won't explain too much there. But over on Varda's side, Varda's an orbital manufacturing company. And so really what we're doing is taking a lot of the research that NASA and other folks have been conducting over the past 20, 30, almost going on 40 years, and trying to say, well, with some advances in technology, is this now economically viable to produce materials in orbit and then bring them back down? From a technology standpoint, where that leads us to is really two components. The first is making an autonomous satellite or material science platform in orbit. It looks like a satellite, it orbits the Earth, but then we have to bring those products back down, so it also is comprised of a re-entry capsule to bring those products back down. And so from Varda's end, and kind of how we're building this out as a business, is working on drug formulations in microgravity, but then also there's a host of re-entry technologies that we're also working on that have their own customer base as well. So our business is pretty bifurcated between commercial pharma interests. Some work with NASA and some work with the Air Force and others.
Got it. So the quick summary is, one, you guys build a spacecraft here that is essentially enables pharma companies or other types of companies to produce, whether if it's pharmaceuticals or other products inside the device.
Yep.
You then launch it up via SpaceX or whatever kind of launch provider that you guys work with. Once it's in orbit, then while it orbits around, you guys actually create, or do research on different products, and then at a certain point, you then bring it back down to Earth.
Yep.
Which is an insane idea, but it's so interesting. And again, to your point, I think the International Space Station has conducted a lot of experiments with pharmaceuticals in microgravity.
Yep.
But I don't think we've ever had a commercial version of this before. So what is the actual benefit of creating things in microgravity? What's kind of why is that special versus doing it here on Earth?
Yeah, no, great question. So if you think about being on Earth right now, there's no way to escape what's known as a gravity well. You have 1 g of acceleration on every molecule throughout your body. It's why your feet are glued to the ground when you're walking around. And if you just think about astronauts floating around in space, they do not experience that same effect. That's what we call microgravity. It's not quite zero gravity, but it's pretty damn close. So we'll say microgravity, but think zero gravity, things floating around. And so if you zoom in on a molecular level, what that allows you to do is to actually reorder those molecules in a different shape or fashion. And so depending on the material, this can have some pretty interesting macroscopic effects if you reorder those crystals in a way that you just can't because you're always in a 1G gravity well on Earth. And so for pharmaceuticals, macroscopic outputs might be a different formulation path where instead of something being an IV bag, it's a subcutaneous injectable. Or instead of being 5 pills a day, maybe it's an inhaler. That's the types of effects that we can have. If you look at other pieces of research, whether it's semiconductors or fiber optics or some of these other pieces that other folks have pursued, let's say up on station, you might have a clearer fiber optic or what's known as a lower attenuation fiber optic, a more ordered semiconductor. There's quite a few benefits that you can get out of this just depending on the material, but it all comes back to this idea that you just have this very, very still controlled environment in microgravity and something that you just truly cannot get back down on Earth because we don't have anti-gravity machines. If we did, we would not be going through that whole hassle of going up to space. And so that's really the only place that we can get that microgravity effect for the length of time that we need.
Got it. And then I know there's been research done on this already. There's been a lot of projects on places like the International Space Station. But are a lot of the research projects that you guys are doing, actually working with pharma companies to actually build medicine, is that completely new, or is that research that's been done already that you can now scale because of Varda?
Yeah. So the research that we're doing is taking a lot of inspiration from what's been done up on the space station, and even going back to research that was done on the shuttle and Skylab, and all the way back to some pretty early days of the space program. People have been wondering what material effects do we get by going to this very, very unique environment.
Right.
And so I would say that we've taken a lot of inspiration from the work that's been done up there. But frankly, there's just a lot of iteration that we have to do to shore up that research to the point where if you're a pharma company, this should not look any different than any other lab tool that you see sitting on your bench. And before you use that lab tool, you probably want to go see it proven a number of times and shore up those data sets.
Right.
And so yeah, we're pointed in the right direction by what NASA and the likes of JAXA and ESA and Australian Space Agency all did. We're now trying to take the baton and race it towards commercial viability.
Right. And so it's an additional variable, right, that all these pharma players can play around with. They can say we actually want to turn on gravity, turn off gravity, and that essentially changes everything in terms of, because it adds one extra variable. Right?
Yeah, think about it like a new knob on your oven,
right?
Like that's how fundamental this is, right? If you have a box and no temperature knob, well, then it's just a box. If you had, if you can go down in temperature, well, now it's a refrigerator. If you can go up in temperature, it's an oven. And now we just give these pharmaceutical formulation people in pursuit of unique pharmaceutical formulation, a new knob to play with. And so there's not something inherently good or bad about that. It's if you can fit this into your recipe in the right way, well, then you might have a pretty dramatic effect. You go from, if you just have a raw cake sitting in your oven and you have no temperature knob, well, you don't have a cake, you have a platter of just batter or something. I don't know, pre-cake.
No, that makes sense. And then, launch, when was the first time when the company was founded, and how long did it take until first launch? Because I think it was really quick.
It was pretty quick. Yeah, it was. I have more gray hairs because of it. It was about 2 years, something around there. Don't quote me on the exact
How is
date.
that actually possible though? Because that seems pretty implausible for a company to be able to get to launch that quickly.
Yeah. Gosh, I don't know. There's a very long-winded answer there, but it's something along the lines of we hired a really good team. We had really good backers. A lot of the engineering team in particular had worked on reentry systems, say over at SpaceX or Blue or some of the other or Boeing before, and so that certainly added to it. But I think taking a step back, a really interesting part of Varda is that the spacecraft componentry and everything that we'll see down there, the re-entry capsules, even a lot of the inspired pharmaceutical work that we're doing, it's not so much novel as it's novel in the aggregate, where it's about putting these pieces that have been done before together in the unique permutation, and also a very unique period in time now where there's just a lot more satellite componentry out there, right? There's rocket launches going off every 2-3 days now. Re-entry capsules are a bit more developed. We're certainly pushing the envelope on that, but I mean, you have the likes of Dragon and Soyuz. You've got OSIRIS-REx landed 2 months before our first capsule came down, which is another re-entry mission that went out to an asteroid, but similar-ish technologies. And so we had a lot to draw on and some good early partnerships, let's say with NASA Ames and NASA Langley, who worked on these types of capsules. And so that let us sprint all the way through. Now, had anybody done it with a team of our size and kind of on that timeline? No, and that's maybe a little bit of our secret sauce, but I won't pretend, we're the first re-entry capsule that's ever existed. We were kind of standing on the shoulders of a lot of people before us.
But it's the integration of everything that makes it novel. But I think that's usually the hardest part is figuring out what's actually doable now, and actually like if that's going to be more doable in the future, and then putting all those pieces together, right?
Yeah, that's right. And I mean, look, like you're knowledgeable about the space industry. It's for us, you started just looking at where the trends were going, right? Like SpaceX clearly was not slowing down on the number of rockets. And then on top of that, SpaceX gets a lot of credit, but look at the number of launch companies that are out there. Like it does not take a complete crystal ball or like Nosferatu type prediction of the future to say there's probably going to be more launch. If there's more launch, the price will probably start to fall down, or at the very least, it'll just be frequent enough where you can start to look at this more as, I don't know, shipping something across the ocean. It's not like this very, very unique shipment, which essentially launch is. And then you just add that up with the amount of satellites that are being launched for, again, we'll look at Starlink, but look at even what the DoD is paying for across, in the US and across the world on these various constellation sets. And so you can start to look at the trend lines of more satellite componentry, more talent going into the industrial base for aerospace, then more launch. And you start to ask yourself, well, what are the business opportunities that are open when all of those things become true? And there's a couple out there, but I think the most interesting and what I hope is the biggest, and I've got a pretty strong opinion on that one, will be orbital manufacturing, with pharma being kind of those first set of products.
Got it. And then, so you've completed mission 2.
Yep.
Mission 2 has successfully landed.
It is not in the lab. It is in DC right now. Well, we'll see 1 when we go down there. So yeah, we're starting to spread them out.
I remember on mission 1, I think the re-entry process took a while because you had to get approval and everything, and it's those things, because I think you were the 3rd commercial vehicle to ever do a re-entry, a commercial re-entry. So I think it's all very new still.
Yep.
And so that's, I think, and then 3rd mission's going out sometime this year, maybe.
3rd mission's in space right now.
Oh, they're in space.
Yeah.
Perfect.
So about, I think it was, again, don't quote me on the day, but it was like 14 or 15 days after the 2nd one landed, we were launching the 3rd one. And so that is in orbit right now.
Got it.
And that'll be re-entering in the next week or so, actually.
Amazing. So I think I'm guessing like from now it's just figuring out how to kind of increase the iteration of how many times you guys go up, can test it, can re-enter, and then if eventually becomes like SpaceX's launches, right? It's like every 3 days, see something go up in space, create something, and then come back.
Yep. Yeah, that's absolutely right. It's really about how we can get this cadence high enough up so then folks that want to formulate, process something in microgravity can just take it for granted that there's a vehicle not only going up, but pulling it all the way back down, in the same way that we can rely really on the launch industry right now, SpaceX, namely, that, hey, when we want to launch, there's a path for us to get up there. If you don't have that, I mean, if you just like don't even apply this thinking to, let's say, the space industry, if you just look at, imagine if every time you wanted to go to, I don't know, you wanted to go do some work in a facility in like Hawaii, but you're like, I don't know when the boat's going to go out. Maybe there's only 2 a year. Maybe it's full. Like, obviously, that's not a good environment to operate a business in. And that's really what the space industry was until very, very recently. And in some ways, it still is for bringing things back down, because there's this bit of a chicken and egg problem going on where, if there's not a consistent re-entry cadence, well, then I'm not going to go invest in trying to develop businesses around it. And that's kind of the unique part of Varda, is that we're kind of said to ourselves, well, the way that you start to uncrack this is by doing both. You push really hard into where there have been those inspiration points from NASA and like continue that research, and that's what a lot of what our pharma team does. And then also you push into really increasing that cadence of reentry. And when those two pieces start to come together, that's where you have something really special that we're working on.
I mean, so for pharma companies, it's essentially going to be similar to like sending it to a lab somewhere.
That's what we hope.
It's just that the lab is in space. It launches and comes back. It's just that you're providing both the lab and the DHL services of going back and forth.
And look, the reason that we're providing, not just the logistics change and the lab too, is because it goes back to that chicken and egg problem, where there have been some inspiration points, but look, they're kind of few and far between. There are a handful of pieces of research that have been conducted on this very exquisite asset, the International Space Station, with rather expensive government employees doing this, that are frankly also working on other things, like learning how to live in space. And so that's where I go back, there are these inspiration points, but I don't blame pharma companies for not jumping into this industry head over heels and saying, saying, I'm going to go conduct 200 pieces of research on the International Space Station, when on the flip side, even if you found something, there wasn't that infrastructure to
Right.
kind of help you go up and back. But yeah, I mean, when Varda's successful, that's what it starts to look at. And one of my favorite facts on that is that going up to space is about the same distance, if not a little less, than going to like an oil derrick off of the south coast of the US, like in the Gulf.
Right.
Like, and nobody bats an eye when you're
Right.
like, oh yeah, obviously we need to go get supplies out there. We need to get products from the derrick and bring it back.
Right.
It's just, we have this, it's so much more difficult because we don't have the infrastructure to go up as opposed to like across the ocean.
Right.
So it's, I don't know, it can break your brain a little bit, but distance-wise, it's really not that far.
Right. That's I've never thought of it that way, but that actually makes sense. And then I think the re-entry point is really kind of, I think, where part of what how Varda differentiates from other kind of services.
Yep.
But I think one of the most interesting things that I found was that you mentioned kind of your business model is a little bifurcated, where you're making things in space, and obviously you'll contract with pharma companies there, but you also get paid money to test kind of re-entry vehicles. Can you talk a little bit about what about that, and then if that was kind of like the plan from the start?
Sure. Yeah, so going back to kind of what we're building over here, and we'll see some of this, it'll make more sense when we go to the floor. Look, the International Space Station is a really great place to do research, but if we wanted to make this economically viable, we wanted to make this process as simple as possible. And one of the ways that you can make a process really simple is by removing humans from the loop, right? You don't have to put on life support systems. You don't have to bring up a human being and keep them living. You can just do the single unit process, that very rather simplistic piece of pharmaceutical formulation work that's difficult, but frankly, it's mixing some things together, heating things up, cooling down. You don't need a human in the loop. And so in service of our goal over on the pharma side, we made the architecture that we made today, which is a free-flying, so unassociated with the International Space Station, really any other space station up there, and these capsules. And so we saw ourselves in the early days as making that entire vehicle for the orbital manufacturing supply chain, research industry, however we want to call it. Now, at the same time, you start to look at that and you say, well, in very short term, Varda's going to have more re-entry vehicle happenings and a cheaper capsule by virtue of us wanting to make it as cheap as possible for the pharmaceutical and orbital manufacturing world than anybody else on the planet. And so it was some very early days where it struck us, and frankly, we had a nice customer demand from folks in and around the re-entry community, and that's everyone from the folks at NASA Ames that work on heat shields for extraplanetary missions. I mean, there was just a paper that came out that some of our research on the first mission was utilized to down select a re-entry heat shield for a Uranus mission that's coming up by the end of the decade. At the same time, other folks that work on re-entry systems in and around the DoD, and so certainly, as we have a cheap capsule that's flying very frequently, we're using it for our own internal purposes. But if other folks can find utility in that, we are a commercial business. We're not going to say no to that work. So.
And it's more like for the clients you work with for reentry, it's more for them to test other kind of reentry vehicles that it's. Not many companies do re-entry, and so you guys are the perfect kind of A/B test to kind of figure out what's good and what's not good.
Yeah, so it's not so much testing other re-entry vehicles itself. It's more testing various components in that really true to life re-entry environment. And it's a slight nuance, but it's I think we might even see some when we go down to the lab. I just can't recall exactly what's down there right now. Where we will take that re-entry capsule that truly we are using for our pharmaceutical missions, and we might put different sensors or different payloads kind of in and around it to collect different pieces of data on that re-entry environment. And so you can almost think about us as a very high-end, very accurate, because we're truly flying through the real atmosphere, wind tunnel. Right, and so high-energy wind tunnels are sometimes called arc jets. So you can, if you squint your eyes, what you're looking at and kind of what that community sees in us as a completely true-to-life wind tunnel, but that's going, Mach 25 through the real atmosphere, and by the way, is recoverable on land. So you get your samples back, and you can go, poke and prod them in a lab however you want to. And so depending on the type of payload that you're flying, there's a lot that you can do just by virtue of the fact that, there are very few people and there are very few opportunities to go on a re-entry vehicle that's at our price point that is flying as frequently as we are.
And to go a little bit back on kind of the monetization here, was this kind of part of the original plan? Because I think a lot of like deep tech companies or hard tech companies, it's very hard for them to find a way to monetize, and it usually takes a long time, or they have to be very reliant on the government. But you've kind of managed to both get pharma and potentially other companies there, but also work with the government as well.
Yeah, I mean, from starting the company, we always knew that we had an interest in where these pieces of technology that we were going to pursue for that commercial kind of North Star, that as we found overlap with government work, we were not going to shy away from that.
Right.
At the same time, we and I think everyone here is particularly interested in being the first company to really solve this orbital manufacturing piece. And so, look, if there was a government customer of any ilk that said, hey, we know you're working on this, but we want you to work on something completely tangent to that, we'd probably say no to that. And we have in the past.
Got it.
But where our technology suite has overlapped with some of those other mission sets, absolutely. We know how to perform on that. We have a lot of folks in and around this company that are very well versed in that type of work, and so it's a really natural fit for us. Even though I recognize that when you're building a business, ours can seem a little odd in that we're doing re-entry hypersonic tests on exotic heat shields that are going to eventually go to Uranus, and then at the same time, we're working on formulations of different drug products.
Right.
But when you kind of piece it together with a piece of technology that we have, I think it makes a bit of sense. So.
Yeah. And then let's talk a little bit about your background here, because I think it's super unique. So before Varda, you worked at Zipline.
Yep.
And what were you doing at Zipline?
Yeah, pretty similar role. So Zipline, for the viewers that don't know, is a drone logistics company that's been operating in both West and East Africa for quite some time. Also did some work with the Defense Department and is continuing to expand and doing really well from there. So I had a pretty similar role where I was looking at different markets for us to take this drone delivery platform that was operating and start to expand from there. And so I spent a bunch of time in Ghana, Rwanda, Philippines, Indonesia, kind of all over the place, and some works with the US DoD. So that's what I was up to over there.
Got it. And so I think
got a lot of miles on my credit card in the process.
That definitely is helpful. I think so. I think that transition to me makes sense. It's from Zipline to Varda.
Yep.
I think before that you were at Stripe.
Yep.
Which there seems to be somewhat of a difference.
Discontinuity. I'm happy you called it out. Yeah.
What were you doing at Stripe, and what led you to kind of join Zipline?
Yeah. Stripe is one of the most amazing companies that's come out of the Valley. I was very fortunate to be there in some fairly early days, doing similar work, BD, some operations, setting up offices, things like that, sales, things along those lines, all the way back to very early days of Stripe. I was doing even some like email support things, just a little bit of everything when it's a small, very fast-growing company. Look, I have a degree in physics. I always had an interest in aerospace and the space world, and so Stripe was an amazing experience to really. I almost look at it like my grad school of here's how you build and operate a truly first-class company.
Right.
And I have nothing but good things to say about my time over there and 5 years there. At the same time, was my passion really in improving payment processing? I think it's something really noble and a lot of people should work on, but I kind of always knew that I wanted to get over into the world of hard tech and aerospace and specifically space tech. And so it was kind of a progression from learning how to build and operate companies in Silicon Valley over to applying that knowledge to industries that I really cared about deeply. So
got it. Yeah. And then I'm gonna go one more step back, because I think when I was looking through your LinkedIn, I noticed you wrote chef, and I think it was 7 years.
Yeah, I did that for a bit. It overlapped with some other things.
Okay, but that seems to be even more of a discontinuity with Stripe.
Yeah.
What was what was your background there, and how did it lead you to go to Stripe?
This is a trickier one to explain, and we probably don't have enough time for the full story. But yeah, I grew up in a rural part of New York. I was really into cooking. That's kind of where my mind went, and I was not one of these that was coding on the weekend, then going straight to Silicon Valley. I was like, I'm going to go become a professional chef. That's where my interest is. Was doing that, but also wanted to pursue a degree in physics, so just kind of kept those pulsing at the exact same time.
Wow.
But then, after college, I went and cooked for a bit, and I was doing it on all my summer breaks. And I actually moved to San Francisco to work in a Michelin star kitchen. And so that's actually what drew me out there. And then the swirling of San Francisco, and this is a much harder transition to explain that we won't get into, drew me over to Stripe, and was very fortunate about that.
Most people, they dream of tech and they go to Silicon Valley. It was very different for you.
Yeah, it was a bit different, and then I got wrapped up in it, and I've not really looked back ever since. But now I can cook for my friends as opposed to having to do it to make a living.
And you still cook.
Obviously, yeah. My wife enjoys it a lot more now. I'm a lot less stressed about the cooking. It's more like as a hobby. So
amazing. And then let's talk a little bit about the organization, because I think this is another very unique point about kind of where we're currently at in kind of hard tech and space tech, is that I think the original kind of space companies, space startups, there were a bunch of aerospace folks, experts in the field, and I think what's really happened is you have this mix of both Silicon Valley and aerospace folks. And why do you think that has happened, and do you think that's really contributed to Varda being this successful?
I mean, look, I come from that environment, so when you're saying that there's more people coming down, it's like data point of one sitting right in front of you. And I would like to think that I've made some contributions that have kind of helped this company go along.
Definitely.
Look, I think it's only a good thing, and it only just speaks volumes to the fact that I mean, you got to give credit where credit's due, where SpaceX and others have really jolted this industry with not only an amount of talent that's just led a lot of these companies to propagate, but also like by bringing launch costs down, by making it more frequent, there's just more business to be had. It was there's some pretty wild charts that you can find online where the space industry itself, you can kind of like square the circle on numbers and show that they're growing, but it was pretty flat for quite some time, right?
I've seen those charts where it's like a slow decline, and then you see SpaceX just go like down.
Well, you see that for like launch costs, but I just more mean like industry itself in space that's resulted from that. And so for a while, I don't blame folks in and around Silicon Valley or other industries to say I'm really passionate about space, but there's not like a whole lot to go grab your hooks into if you're not going to go do one of these wild like NASA missions or go put up a handful of DoD satellites every year. It just wasn't a particularly big industry. And so I think, as the industry itself is expanding, in large part because of the new infrastructure that we have and the amount of talent pouring into it, then frankly, if you're entrepreneurial, it's just an even more exciting place to be. And we need more talent down here. So, all my friends up in Silicon Valley, I hope more and more come down to work at these types of companies. I think they're really important. And frankly, they're a lot of fun, as stressful as they can be. I mean, you get to make like shooting stars. Like that's pretty cool. I didn't get to do that at Stripe. No offense to the Collisons on that one, but it's pretty cool.
Yeah. I think one other thing that's really unique about, this place is it marries, top-end hardware folks with top-end software folks. And sometimes you have people who can do both.
And top-end pharmaceutical folks. I might even throw that one.
I mean, how does that all work together? How do you hire experts from both fields, or is it kind of do you find folks that understand both sides? Because oftentimes you have to understand both, all three sides, in order to actually build the products that you build here.
Yeah, I mean, look, it's a little bit of column A, a little bit of column B. I won't pretend that there's a secret sauce to it. I mean, I think what Varda's done a really good job of is finding people that maybe had a bit of a curiosity about the aerospace world, but maybe they were in a different domain, and giving them that path to cross over and really contribute. And I think that goes, even over on my team, whether it's Gov Affairs or BD or in marketing and comms, a lot of the folks don't have a background necessarily in space, but they've got some interest in it, right? I won't pretend that we get a lot of people that come in and they're like, well, I was not interested in space at all. I wasn't following it at all, but maybe a little bit of interest, and they were working in another field and didn't see a path to come over and really starting to expand the pie of folks that we can go after. And I think, that just benefits the industry overall to have this great talent pool that's not just these folks that have worked for 20 years at Boeing. It's maybe a year or two at an aerospace firm, maybe a handful of years over at an autonomous car company, and then draw them back over. So,
got it. Yeah. In terms of vision, kind of move looking long term, and I don't know how much you're allowed to talk about this, but obviously increasing the cadence of missions, right? Increasing that side, I think makes a lot of sense in the long future, right? Do you as we go to Mars, as we go to different planets, do you kind of envision Varda to be kind of this last mile logistics kind of company where you might build a lot of things in space, there's a lot of parts moving back and forth, and then you guys provide the last kind of re-entry capsule to different planets?
Yeah, I think where Varda really wants to sit in this picture is, and this is both as grandiose as you want it to be, but there is a unsolved problem of nobody has made low Earth orbit economically viable for essentially anything besides telecommunication, right? Like seeing and sensing. Those are the businesses that are in space. But at the same time, like at some point, these things start to saturate. Like you kind of only need so much seeing and sensing. It's a very big market, don't get me wrong, but really cracking the nut on how we utilize microgravity to bring space-based materials back that can affect everyone on Earth that is a grand challenge. Like that is so big to tackle, and that is what we are squarely focused on tackling. I think like as some of these other, we expand to the moon or Mars, we will, for large part, leave that to other people while we continue to double down on just how do we industrialize low Earth orbit. Because again, for us, it's zero gravity is where you see the majority of the effect. If you have a little bit of gravity, let's say on the moon, there's some interesting stuff there. Maybe you make some telescopes or go mine it for helium-3. I don't know. That's not my expertise. But as far as where we see the biggest business opportunity, it's really in low Earth orbit. Now, could you take those materials and utilize them for interplanetary missions? Maybe, but I would be hard-pressed for anybody to convince me that there's going to be more people, just market size, going to those other planets than there is like right down here.
Makes sense.
And so we are interested in going to space to serve this market.
Got it.
Yeah.
And then can you talk a little bit about, the city we're in, El Segundo, has a history, obviously, with SpaceX being here. Before that, with, Chevron, space shuttles.
All the way back to like Hughes.
Yeah. But I think like all that background is obviously very important in building kind of the culture here and building, a lot of the talent here. Can you talk about, the importance of being here in El Segundo?
Sure, absolutely. Look, like Varda could not have started anywhere else besides this part of Southern California. And for a number of reasons, look, it's like in the bones of the building. I mean, this building was used for avionics control boards way back in the Apollo era.
Wow.
It was a skateboard distribution factory in between there, but but I mean, just from like the buildings that we have access to, right? There's a 60,000 square foot facility. You don't have that in something like San Francisco, even in the South Bay. You're not going to see it as much. But also, the talent has not really left this region, and with SpaceX coming about and really injecting that much more new talent and new energy, and it's a pretty nice place to live. You start to see this talent density, infrastructure density. Certainly the city governments are very welcoming to this kind of community around here. And so, you've seen this proliferation of both talent and also just leading to some pretty amazing companies. And so it makes it's a pretty cool place to be able to start and work on something.
Got it. And then kind of last kind of questions from me. I think two of them, two last questions. One of them is, what keeps you up at night? Whether you can take it as a good thing or a bad thing. I think there's both ways to take it, but what keeps you up at night?
Yeah, one, we're going to have a bunch of re-entry capsules that are sitting around our office pretty soon, and like, where do we put them all as they start like actually?
There's a space issue here.
Yeah, there's like we can only give so many to museums and things like that, but we're just going to have a pile of them.
Man, I wish our offices was big enough.
Yeah, I don't know. The ITAR restrictions might make that a little difficult. But no, the other side is look, nobody's built a business like Varda or really solved this orbital manufacturing piece before, right? There's you and I do not have pharmaceuticals sitting on our shelves that were manufactured in space. Like we just don't.
Right.
And so what keeps me up is like, making sure that we're continuing to make progress towards this what I think is a pretty amazing thing to work on, which is doing that for the first time in human history.
Right.
And there is not a roadmap that I can go follow for that, or that any of us can go follow for that. And so maybe just the anxiety that comes with being given the opportunity to actually get to work on something like this.
Amazing.
Maybe that's the best way to put
No,
it.
that's a great answer. Last question. In your opinion, what rule do you think people should break, and what rule should people follow?
Oh, wow. Okay. I don't know. If you go on the career side, like careers don't have to have a linear path. And I think too many people kind of think that they do.
Right. There's like a progression.
Yeah. It's like, kind of go work on the things that are most interesting to you and try to find dotted lines between that. And I think maybe that's like a little bit of like a broken rule. And certainly data point of one, like sitting right in front of you, it's somewhat worked out for me. And then what was the other part of like that
what rule should you follow?
That should be followed. I don't know. Don't put your elbows on the table or something, like just be nice to people.
Yeah.
That's probably it. Yeah.
No, it's great. It's a great rule. Cool. Well, thank you for the interview today. I'm excited to go see.
Yeah. Let's go see some hardware.
Yeah, let's go.
Cool.
Thank you.
You can see some hardware from our earlier flights.
Wow. Segundo.
Okay, we'll get lunch just got served, so if you want to like
Oh, got
Go
it.
get some
Thank you.
tacos or
Thank you.
something.
Very cool.
Yeah, and you can see a photo from our first re-entry right there.
So this is the first reentry, and
Yeah, this is an
landed
image.
in Australia.
This was in Utah Test and Training Range.
Oh, Utah, okay.
Yeah, Utah, just west of Salt Lake City.
Got it. Got it.
Okay, yeah, we can just stand like kind of right here.
Okay.
Okay, we can film this.
What did I?
Okay, so what we're looking at over here is
so
right there. What we're looking at over here, this is our heat shield for an upcoming capsule. So you can see,
Oh, wow.
those are the tiles that keep the inside of the spacecraft cool. So we can, after we formulate pharmaceuticals, we prefer if they don't get the temperature of the surface of the sun.
Right.
And so that's what keeps us really cool. So if you see any of our videos online, when you see us re-entering and kind of all of that, what's known as ablation, kind of coming off, you can think about that as that's that heat shield sweating off the heat as the friction from re-entry is occurring.
And then do you guys reuse a lot of the parts that come back, or is it kind of right now you're building everything from scratch?
Yeah,
every single time?
we'll reuse some components of it. We won't reuse the heat shield, but again, those aren't the major cost drivers.
Right,
so there
right.
are other ways for us. When you think about reusability, you're doing it because you're trying to drive costs down. There are other pieces that we can, bigger levers, let's say, than reusing some pretty simplistic pieces of equipment.
Makes sense.
And you'll see that when hopefully we can take a peek inside the capsule.
Yep.
These capsules are like automotive tooling.
Right,
It's like pretty, burly pieces of metal as opposed to anything overly exquisite. And that's by design, right? Every dollar that we add into our capsule is a dollar we have to charge to our end customer.
Right.
So if we think about economic viability, it's like, get your BOM costs down as much as possible. Make it as simple as possible. So, but yeah, that'll be going to space
really cool.
in probably around the end of the year, if I had to guess. I'm not sure which vehicle that's going on.
Okay,
but,
okay.
this is the W1 capsule. So this is what we just saw in the lobby.
This is the first one.
This is the first one, yeah, W1. And so you can see, the heat shield at first looked a lot like that heat shield that was over there, but now it has gone through atmospheric re-entry. And so, yeah, this is the first commercial re-entry vehicle that landed on U.S. soil ever, which we're really proud of. Real quick, you can see, there's actually a payload mounting bracket. So you can see how, you can film that. So you see how, that's that triangle shape that you're probably used to with those three brackets.
Product's
over
like in the middle of that.
Yeah, we can put payloads up and bottom. But it just gives us kind of a normalized mounting surface. So
Makes
then
sense.
as we're working on payloads internally, which I can't show you, unfortunately, or we're getting them from, let's say, the Air Force or NASA, it gives us places to put them.
And then is there any effect like launching and then like coming back down on the product? Because like, obviously you're testing things in microgravity, but once you come down, then it's no longer in that condition. Yeah,
no, it's a good question. On a molecular level, once something's in, we have to prove this out, but generally, once something's in a crystal form, it's very stable. I mean, the best example that I have is if you ever go into a pharmaceutical lab, they've got desktop centrifuges that spin at 500,000 Gs. They just use them for filtration and separating things.
Right.
They're not breaking the molecules in that process. We only pull 10 Gs, 12 Gs, something like that. And so as violent as the environment looks like, once they're in this crystalline form, it's locked in.
Got it.
The effect is locked in. If you want to think like we have trapped the microgravity, but more just, when something's in a crystal, it's very stable.
Got it.
Or you suppress the crystallization, then you freeze it, right? It's like when it's in that melted state or liquidy state or low viscous state, that's where the microgravity really happens.
Got it.
If we were to leave it in that state, do something in microgravity, leave it in that state, and then bring it down, it's like, why do we even bother?
Right.
Okay, let's go this way.
Okay.
Oh, you want to see something cool? Here.
Yeah.
You can film this. So, here.
Oh, it's heavy.
This is the ballast for the front of our. Here, you can film him trying to lift this. This will be fun.
Oh God.
Okay, so this is the ballast that goes in the tip of our vehicle to make sure that it's oriented the correct way as it's flying.
Like on the bottom.
It's inside, but
it's
inside
inside.
Of the bottom.
Okay. Oh God. That's heavy. That's really heavy. It's really.
You want to try?
Yeah. It's really heavy. It's just really heavy.
Here. I won't let go.
I'm scared. Oh my God, I can't.
How heavy is that?
I don't know. It's tungsten though, so it's the highest density metal.
Okay. Oh,
but it's just it doesn't. Your brain doesn't want to. I mean, you can even like these. These are.
But
same metal.
Yeah, it's same metal, but it's heavy. Yeah, you can tell it's heavy.
Just a kind of ballasting to go in the capsule. Because when you're going that fast, if think about it like a badminton shuttlecock, but like Mach 25.
Right.
So you really want to make sure it goes the right way. And so
Right.
a lot of that is actually getting the center of gravity in the correct spot.
Got it.
We explain these are, you can film these are hardware in the loop, or HIDL racks.
Got it.
And so what we do here is we essentially pull out all the, very simplistically, we pull out all the electronics of our vehicles, and then we're able to simulate those vehicles of what would happen in space. Think about this as this is our test rig before we go to space. It's everything in the vehicle but the vehicle itself. It's all the brains, it's all the sensors.
So this is testing essentially the electronics on it, like make sure it moves, but like without like the microgravity, all that kind of stuff.
Exactly. We can kind of say, hey, pretend you're in orbit.
Right.
You see the sun now, you don't see the sun now.
Right.
How do you react?
Got it.
Did it react in the right way or the way that we wanted it to?
Got it.
And so it helps with a lot of software development.
So that's like all of this.
It's a lot of this
area.
section of the lab.
Okay.
And then what's kind of cool over here, and it's not running, but we can get a kind of peek on it. So this is kind of cool, and we've started publishing on this. So this is what we call our hypergravity machine. Fancy way of saying that it's a 10-foot diameter centrifuge. Okay. And so for pharma processing, we can't simulate zero gravity down here, right? If we could, we want to go on a rocket, we want to go to space. But what we can simulate are higher G loading. So you've got 1G right now, we're experiencing that. But if you spin around, you can get to 2G, you can get to 3G, 4G, 5G, just depending on how fast you spin. And so what this tool allows us to do is do predictive modeling at higher G loads, so then we can start to guess what might happen at 0G.
Interesting.
And so we've started publishing on this. We're seeing some pretty cool effects where we're able to actually say, hey, if we have 10 molecules and these 3 are more gravity sensitive than the others, gravity sensitive, we probably want to fly those 3 versus the other ones.
Interesting.
So I can send you some papers on it, but our pharma team's spending a lot of time on this as a process development step before we go to zero gravity.
Right.
Because while space is getting cheaper and more frequent, I won't pretend that it's the same as driving down the road. I'm not. I don't have that much hubris.
Yeah.
So.
I mean, we're still not at the point where you can fly every 5 days, every week.
No, every day. Drive it down the road.
Right.
We're getting there. With any luck, we'll get there, but we're not there yet.
Makes sense.